Hi there and welcome to another video from Hegarty Maths. It's Mr. Hegarty here, and in this video we're going to solve some equations with algebraic fractions in them. I want to start with something you already know. Previously we've simplified the following algebraic type of fractions and algebraic expressions. We don't have an equal sign, so all we can do is simplify these. Pause the video and double check you can do that. Well, this is exactly like adding fractions with numbers. When I told you to simplify them before, you can only combine these if they have the same denominator. So you need to work out the lowest common multiple of 5 and 7, which is equal to 35, and make both the denominators 35. Okay, what did I have to do to that 5 to make it 35? I needed to multiply it by 7, so I must do the same to the top. What did I do to that 7 to make it 35? I multiplied it by 5. What does this therefore become? Well, it would be 7x. This therefore would be 5x. And 7x over 35 add 5x over 35 is going to be 12x over 35. And that is this expression here simplified. It would be the exact same in this case with the subtraction, other than we'd have 7x over 35 subtract 5x over 35, and we would get ourselves the simplified answer 2x over 35. And I need you to be able to do that skill for this video, where we're actually going to solve equations with these type of algebraic fraction expressions in them. Let's go straight on to an example. Suppose you're asked to find x in this case. Solve x over 5, add x over 7 is equal to 3. The first thing you're going to do is simplify the algebraic fraction. We're going to simplify this into one nice neat thing. So it's exactly as we did before. We're going to work out the lowest common multiple of 5 and 7, which is 35. Make both of them 35. I had to multiply this by 7, so this is going to be multiplied by 7. I had to multiply this by 5, so this numerator must be multiplied by 5. And we would do that. And we would, at this point, say this thing is equal to 3. We would therefore collect this up and simplify it to say 12x over 35 is equal to 3. Now we want x all by itself. We want to solve for x, find x. So to undo the divide by 35, I'm going to multiply both sides by 35. Okay, and that would cancel the 35 here and here, and I would get myself that 12x is therefore the answer to 3 multiplied by 35. 3 multiplied by 35 is like 3 multiplied by 30, add 3 multiplied by 5, which would be 90, add 15, which is 105. So this is 105 here. And then we need to divide both sides by 12 to find x by itself. So we're going to divide that by 12, divide by 12, and we get ourselves that x is equal to 105 over 12. Am I done? You've got to be careful and double check whether this needs simplifying. 1 add 0 add 5 is 6, and 6 is divisible by 3, so this can be divided by 3. Obviously 12 can be divided by 3, so we're going to divide the top and bottom by 3, simplify that fraction there, and we get ourselves 35 over 4 when we do that. And this is the answer. We leave it as an improper fraction and we're done. We have solved this, we have found x. It's really hard to substitute back in and check it's right. It's better you just work really carefully and get it right the first time. Next one, pause the video and have a go at this. Same thing. We're going to take the left hand side and we're going to make it over a common denominator. The common denominator is going to be the lowest common multiple of 2 and 5, which is 10. So I'm going to make that be a 10. I'm going to make that be a 10. I'm going to put in my add sign. I had to multiply this by 5, so I'm going to multiply this by 5 and get myself 15x. I had to multiply this by 2, so I must multiply that by 2 to get myself 2x. And don't forget, this expression here is equal to 3. Collecting that, 15x over 10 add 2x over 10 is 17x over 10 is equal to 3. And now to get x by itself, I'm going to first multiply both sides by 10 to get rid of that factor of 10 on the denominator. So multiplying by 10 undoes that dividing by 10, and I will get myself on the left hand side 17x is 3 multiplied by 10, which is 30, and then I'm going to divide both sides by that 17, and I'm going to get myself that x is therefore equal to 30 over 17. Have a quick think, can I simplify? I can't because 17 is a prime number. And I'm done. Next one, have a go at this. Pause the video. Okay, I'm subtracting fractions here. I'm just going to make them have the same denominator. The lowest common multiple of 2 and 6 is 6. Okay, so I'm going to make them both 6. All I have to change is this one here. Make that a 6. Keep that as 5, 6. I had to multiply this here by 3 to make that be a 6, so I better multiply that by 3 and I'll get 9x like that. And don't forget this thing is equal to negative 1. 9x over 6 take away 5 over 6 is going to be 9x take away 5 over 6 is equal to negative 1. They're just subtracting the numerators when the denominators are the same. And now I need to solve for x. So what I'm going to do to both sides, I'm going to multiply both sides by 6 to cancel this divide by 6 here, but I've got to do it to both sides. I'm going to therefore get myself this 9x take away 5 is going to be negative 1 multiplied by 6, which is negative 6. Now I'm going to add 5 to both sides to undo that take away 5, and I'm going to get myself therefore that 9x is negative 6 add 5, which is negative 1, and my last step is to divide both sides by 9, and I'm going to get myself x is equal to negative divided by positive is a negative answer, 1 over 9, leave it as a ninth, and we're done. Last one for you to try. Right, this one's a tiny bit trickier. We've got to, this again is an algebraic fractions, we need them both to have the same denominator. What to choose? Well, they both are going to have an x in it because of this x. So I'm going to stick an x there and I'm going to stick an x there. And what you can do is just think what the lowest common multiple of 3 and 2 are, and that's 6. So I'm going to have a 6x on the bottom. Now 3x goes into 6x twice and 2 goes into this 3x. So you choose it by realizing you need the algebra in both places, and you just work out the lowest common multiple of these two, and that's your coefficient. Okay, what do I need to do to this to get 6x? I double it, don't I? So I must double the top, and that's 4. What did I have to do to the 2 to get it to be 6x? I multiplied by 3x. I better do that to the top as well. So I'm going to get 21x. And all of that is equal to 4. Then I can just subtract the numerators. 4 subtract 21x over 6x is equal to 4. I don't like the 6x on the denominator here, so to undo that I'm going to multiply both sides by 6x, and that cancels that 6x on the denominator, and I'm going to get myself therefore 4 subtract 21x is 4 multiplied by 6x, which is 24x. Now I want most of the x's on the left hand side, so I'm just going to rewrite this as follows. 24x is equal to 4 subtract 21x. I want all the x's together, so I'm going to add 21x to both sides. Therefore I'm going to get 24x add 21x is going to be 45x, is going to equal the 4 that's left over here. And lastly, I need to divide both sides by 45, and I'm going to get myself the answer, which I'll write over here. X is equal to 4 divided by 45. And I can't simplify that, and I'm done. And that's it for this video. Thanks for watching.